Okay, so our research is about a different evaluation metric for concept erasure methods in diffusion models. So concept erasure in diffusion models, let's say you have diffusion models that's very that can generate all sorts of images, and you want to limit the generation of some type of data. So let's say you want to limit the generation of nudity. And there are many methods that do that by actually changing the model, fine-tuning the model with different prompts that contain nudity, so that when the user will ask for images of nudity, it will not generate it, as we see here. And the way these models are evaluated is by giving them a bunch of prompts that have nudity in them in different variations, and seeing if whether the outputs are actually have nudity images. And the thing is, we saw that and asked whether that's enough for evaluation. And we actually saw that if we take an image of nudity, if we start with that, and we invert the model, we go the other way, we can actually extract latent that can be used for inference to actually generate the forbidden concept. So in other words, it's if we have a model that is not allowed to generate parachutes, we're able to actually find latent seeds that can be used to generate parachutes. And okay, so we need to make sure about two things with that, because diffusion inversion is very powerful, but we need to make sure that first we have an image of a parachute, which is that's the case for all the concept erasure methods that we checked. It's not a problem. But the other thing is that we need to see that the latent we got is something that is not far-fetched in the latent space and something that is plausible. So that's mainly our quantification. Okay, so we came up with a metric that says we want to show that we that a model that was supposed to forget a parachute actually does that. And that is done by looking at the distance between the images of the erased set to normal distribution samples. And we also want to make sure that non-erased images or latents that for images, normal, natural images, will also be close to the normal distribution, because we want to see that the generative model we did not harm the generative capabilities of the model. So after we did that, we thought, okay, maybe we find something in the space, something, one latent, one specific area that does that. So we wanted to make sure that it happens in the whole space. So actually initialized using different images, initialized different areas in the space, and we found many latents that are far away from each other in the latent space that can all generate the concept image, the forbidden concept image. We even extended it we did it on 1,000 images, and we found 1,000 pairwise, 1,000 latents that are pairwise distant from each other enough in the space that all can generate a similar image of the Van Gogh here. And that leads us to the conclusion in the end that true forgetting is not that easy. And we also have had a surprising result about the power of diffusion models, that when I take an image of a church, I shuffle it, I invert and reconstruct it and get another shuffled inversion image, and I deshuffle back, I still get an image that has the concept of a church. So when we're talking about forgetting or erasing, it's not just about things that the model knew or something in the training data, but it's also in just things that the model is able to create and we want to deny. That's it.